All right, I'm going to walk you through part B of this egg problem that we mentioned in class. Part A was a normal distribution problem. I think most of you did pretty well with that. But let's go to part B. In part A, they told you that the full containers, full cartons, which is 12 eggs and a container, has a certain mean and a certain standard deviation. And then in part B, they told you what just the container weighs and standard deviation. And what we're trying to figure out now is about random variable x, which is going to be a single egg. That's one thing we don't know. We know what the full container weighs, and we know what just the container weighs. A full container, though, has 12 eggs plus a carton or a container. So one of the things we may want to write down just to kind of keep our mind straight here, a full container consists of 12 eggs plus a container, or they use the word carton as well. And it seems a little bit tedious to write this out this way, but it's really important to realize this is an addition problem. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A full container is 12 eggs plus the container or the carton, the cardboard that it's contained in. That's the random variable f. And so for the mean is pretty straightforward because the mean of f is given to us. That's 840 grams. And the mean of the sum is just going to be the sum of the means. And so we're going to have 12. Here's where we can use a little bit of algebra. We're going to have 12 means of eggs plus 1 mean of a carton, which we know they gave us that to be 20. So we can set up a very simple algebraic equation where it's 840 equals 12 eggs plus a carton. And now we subtract 20 from both sides and divide by 12, and that'll give us 1 egg average weight. And if you do that on a calculator, 820 divided by 12 is about 68 1/3, 68.3 grams. So that would be our average egg weight. So the mean's pretty straightforward. When we get to standard deviation, however, that gets a little trickier because it's not standard deviations that add up, it's the variances that add up. So we're going to actually have to go through variances to get standard deviation. So we'll get to standard deviation, but first of all, we have to go through variances. So what we know is that the variance of the full carton is going to be the sum of 12 variances of 12 eggs. So the variance of 1 egg plus a variance of a second egg plus ... 12 of those, plus the variance of the carton. So the variance of the full we can figure out by squaring 7.9. We're given the standard deviation. So we can find the variance by squaring the standard deviation. That's the variance of the full carton. And that's going to equal 12 variances. Here's where we can use a little algebra. That would be 12 variances of 1 egg plus the variance of 1 carton. Well, 1 carton has a standard deviation of 1.7, so the variance would be 1.7 squared. So similar to the equation that we had back here for means, we have a very similar equation, except it's with variances. The variance of the full carton equals 12 egg variances plus 1 carton variance. And now we just do a little algebraic equation, a little algebra solving. So 7.9 squared minus the 1.7 squared divided by 12 should give us the variance for 1 egg. So if you do that carefully, you should get 4.96, I believe. 4.96 is the variance for 1 egg. But of course, that's variance, not standard deviation. So to get standard deviation, we have to square root 4.96. And when you do that, you get approximately 2.23 grams. So the standard deviation for an egg would be approximately 2.23 grams. That's the one that's a little harder. But when you see it written out and when you see the steps and you break it down into pieces, it's not that hard. It would be really hard to do that all in one big step in your head. So just keep in mind these problems many times are not that bad if you take the time to write out what you're dealing with. And so when you see the 12 eggs and the 1 carton adding up to the full container, well, then it makes it a little bit easier to write these equations. So let me know if you have any questions, and I'll see you later.